talk about the remainders. Probably this chapter is relatively easy to you. Okay, what is the definition of the quotient and remainder? You know, if you have a number, let me give you an example first, okay? If you have a number divided by another number, right? So that's what we do, right? And for example, 14 divided by, divided by 5, right? And then, you know, you just use a definition, right? So this is you already learned this. It's the 5 and the 2, 10, and the 4 is a remainder, and the 2 is a quotient. So the question is, how do you express it? So in the school, you probably are told that 2 are and 4. Okay, 2 means a quotient, 4 is a remainder. Okay. Okay, so this is a notation. Now, can we express it in a slightly different way? Well, we can do like this. 14, when you divide it by 5, usually you can express as a fraction. Maybe you already learned fraction. 14 divided by 5 can be expressed as a fraction. So the quotient is 2, okay? And the remainder is 4. So this can be, 4 is still there. You cannot divide it, okay? So this is an identity, but you can also multiply both sides by 5. You can express 14 as 2 times 5 plus 4, okay? So this is another identity. And you check that, right? The quotient times the divisor, okay? This is called let's give the name here. Dividend. And this is called quotient. And this is called a divisor. And this is called the remainder. Okay, I have named that. So that's a relationship. If you are given 3 of them, you can figure out the other. Okay, so the dividend is going to be quotient times divisor plus the remainder. Okay, so this is this is a relationship. Now, in general, we can also, if in general, if some number, you know, let me put a little more structure. It's divided by divisor, right? Then if you get a quotient, then you also get a remainder, okay? That's called quotient. Q means quotient, okay? Then this is a remainder. Okay, this is a quotient. Then you have the general relationship is a P times, divisor. It doesn't matter which one is first, Q plus R. That's another formula we have. Okay, so we get, you know, you have a very specific formula, and then you have a general formula. Okay, so what I'm going to do today, let's talk about some examples. So the first example, if the remainder, when the remainder is 0, that means the number is divisible by P, right? For example, a number is divisible by, when the remainder is 0, then we say the number is divisible by the divisor, okay? For example, 10 is going to be divided by 5, right? It's going to be 2, so 2 times 5. So then we say that 10 is divisible by 5, but you can also say that 10 is divisible by 2, because 2 is also can be viewed as a divisor, right? So it doesn't matter. This one is not there's a order doesn't matter here, okay? So then we say that 10 is divisible by 2 or by 5, okay? So let's look at the following problem from Yeah, let me show you an example. Okay. Okay, this is a typical example we will ask. So a number a number has a remainder of 2 when it's divided by 4. Okay, and it also has a remainder of 2 when it's divided by 6. Okay, my question is, what is the smallest possible value of this number? Okay, now how do you solve this problem? We okay, how do you solve this problem? Well, first of all, you see they have the same remainder, right? So a number, if you divide by 4, has a remainder 2. So that means the number, if you minus the number minus this number minus 2 is divisible by 4, okay? Since it has the same remainder, okay, if you divide by 6, so this same number is also divisible by 6. Now why? You see, when you divide a number, right, you get a remainder, you get quotient. But if you subtract the remainder from the original number, then that number is going to be divisible by the divisor you're using. Okay, so so for example, 14, right? When you divide by 5, you get quotient 2, and the 5 is a divisor, and the remainder is a 4. So when 14 minus 4, it's 2 times 5. So that's why it's divisible by 5. Okay. So the same here. We are looking for some number, and that number I cannot find the number directly. But I subtract the same remainder 2. I find out it's divisible by 4 and divided by 6. Now, what is the smallest possible number? Divisible by 4, divided by 6. Okay. And that number should be greater than 2. Okay, of course, that's otherwise it's true. Okay, and then 4 is 2 times 2, right? 6 is 2 times 3. A number divisible by 4 and 6, the smallest number you can have is what? It must have a factor of 2. It must factor of 3. You have double 2, okay? So that number should be equal to 2 times 2 times 3, right? That's the smallest possible number you can have, divisible by 4 and 6, okay? So that is going to be 12. So your answer is going to be 14. So we know a lot of students already get answers, okay? So, so I'm going to ask you to do another problem. Okay, so we have okay, so we have another problem. A number has a remainder of 3 when it's divided by several numbers, okay, and find the smallest one, okay. A number has a remainder of 3 when it is divided by, okay, 4, 5, 6, 7, respectively. You know what I mean, respectively. Right? Find the number. This number, of course, should be greater than 3. Okay, so otherwise it's true. So we say this number is greater than 3. Okay, so find the smallest possible value of the number. Okay. All right. Can you do that? You know, please take a pencil out, a piece of paper, okay, and then try to work out by yourself. I want to see someone who can show me the answer right now. So there's a number gives you the same remainder when it's divided by 4, 5, 6, and 7. And can you figure out the smallest number? Okay. Justin, please mute your phone, microphone. Daniel, can you figure it out? The idea is similar. Well, the previous example, we only have 2 divisors, right? And we get same remainder. Now we have more. So this, you have to transfer this problem to the following. The number minus 3 minus the same remainder is divisible, right? So the number is called, let's call it just say x minus 3. So the remainder is gone. This is divisible by 4, 5, 6, and 7. But 4, 5, 6, and 7, you know that they are they have a common factors there. Okay, so 4 is 2 times 2, 6 is 2 times 3. So this number should be divisible by at least by 2 times 2, and you already have a 2 there, so you don't need another 2. So 2 times 2 times 5 times 3 times 7. Okay, so when you multiply this out, right? Well, it's easy, you know. I don't know how to get it. Yeah. So this is a 21, and this is a 10, so easy to calculate, right? So 21 times 2 will be 42. 42 plus 8 is 0 there, okay? So 420. Oh, Daniel, yeah, got 423. Okay. All right. How do you get 420? Yeah, you know, you added them together, move 3, yeah. X 420 plus 3, it's 423. So that will be the answer. Okay, good job. Okay, so those are the problems we. Now there are some other problems we don't have a common denominator, a common remainder when you divide by different divisors, but we still able to. Yeah, we still can do that, and let's see. That's different numbers. Okay. For example, a number has a remainder of 2, okay, when it is divided by 4, okay? Now it has a different remainder. It has a remainder of 4 when it is divided by 6. Okay, so this number should be greater than 4. Okay, yeah, we have to mention that. My question is, what is the smallest number for this this property? So find the smallest possible value of the number. Okay. Yeah, I give you a minute to think about, and yeah, this number when it's divided by 4, right? It's going to be 2, as the remainder is 2. Okay. Now when divided by 6, the remainder is 4. Right. So here we have to separate in 2 steps. We don't have the common remainder here, right? We don't have a common remainder here. So what I'm going to do, I'm going to use the second one. So the number must be in the form, right? Divided by 6 must be 6 times the quotient plus 4. Okay. So this number is greater than 4. So you can have 10. You have a 10, 12 plus 4, 16, right? And then 22, and so on. So then you look at when this divided by 4, right? Divided by 4, what is the remainder? You find out that when 10 divided by 4, the remainder is going to be 2. We see that, right? So this is the answer because 10 is given 2 times 4 plus 2. Okay, so this is a match the first condition. Okay, it matches the first condition. Okay, sorry. Yes. Okay, so great. Yeah, let's do one more problem, then we can move on to the next topic. Okay, so a number has a remainder of 3 if it is divided by 4, and it has a remainder of 6 if it is divided by it's divided by 8. Okay, so what find the smallest. This number should be greater than 6. Okay, find what is the smallest possible value of the number. Okay. And this is maybe complicated. Yeah, you have to try one by one. Okay. All right. I should say that it's possible there's no solution. Okay, it's not always happens. Okay, so let's look at, okay, so not always have a solution actually. So as a number, yeah, this is the power of, the number is divisible by 8, right? 8 times quotient, right? The remainder is 4. Now this number is going to be divided by 4, right? You should gives you the remainder of 3. Now, do you think it's possible or not? Because when 8 times the quotient plus 4, this part, okay, this is 6, yeah. All right, so this part is divisible always by 4, right? Then 6 divided by 4 gives you a remainder of 2, okay? So that number, if meets the satisfying second condition, then that number, when you divide by 4, the remainder is always 2. Because when 6 divided by 4 is a 1 times 4 plus 2. So this number always has a remainder of 2 when divided by 4. Okay, so so this is a number, if it meets the second requirement, okay, always has a remainder of 2 when it is divided by 4, okay? As long as it's meet the second condition, okay? So remember, if you divide a number by a divisor 8, and you don't know the quotient. It's okay. And plus the remainder. So the number, you probably already figured out, we tried the number, the first number you say could be 8 plus 6, and that is going to be 14, right? Then second number is 16 plus 6 is 22. So when you divide by 4, you always get a remainder of 2, okay? And then x could be 24 plus 6, right? It's going to be 28 when divided by 4, right? When divided by 4, 30, yeah. When divided by 4, you always get remainder of 2, okay? So you should see that it's possible, it's always remainder of 2. So then you try to prove that in general, okay? So they always, they all have the same remainder of 2 when it is divided by 4, okay? Yeah, but this is just from example you figured out. But you can also prove that in general, right? Because the general form of such a number is 8 times something plus 6. But 8 times something is always divisible by 4, so you don't worry about that. So remainder is determined by the 6. But 6 divided by 4, the remainder is always 2. All right, so this is about the remainder problem, okay? Now our next problem is using the remainder to solve the problem. Okay, I have a string of flags, okay? Let's keep going like that. And I have this is a red color, okay? And how many red colors? Yeah, red color. Then I have a blue, then I have a white, and white. Then I repeat it, okay? The pattern is repeated forever, okay? So the next one is always, it's also R and so on, okay? It's repeated. My question is, what color is the 100th flag? Yeah, what color is 100th flag? Okay, so you needed to know in each group how many flags there. 9 flags, right? So 9 flags. Each block, there was 9 flags. So this block is repeated. So 100 divided by 9, okay? So 100 divided by 9, the quotient is 11 times 9 plus 1. So 1 is a remainder. Okay? So there are 11 blocks of flags. The last one plus 1 more. The last one is the first one in the block. That should be the red. Okay? So that's why the flag, the 100th flag is red. Okay? Got it? Right, I'm going to ask you to do another problem. It's in the same category. Given a sequence, okay, 3, -7, 5, -3, and 2. Okay. So then repeat 3, -7, 5. -5, -3, and 2, and keep going. Okay. So this is a long sequence of numbers. Find the sum of the first 100. I'm going to use 2019 terms. Okay. Yeah, please do that. How to do this? You have so many terms there, right? Lots of people already give me the answers. Come on, stop. I know you got 0. Are you sure it's the right answer? Don't copy others' answers. Sophia, can you do that? No idea? So Justin says, yes, I'm sure, that's 0. (2019). Okay, so when you see this is a group, right? All right, so 3 plus -7 plus 5 plus -3 plus 2 is going to be what? It's going to be 0. Okay, no problem. But how many blocks there among the first 2019? You know, you can have, one block, right? Each block, you know, a group of numbers. There's a sum, the sub-sum is going to be 0, right? So you can add the 5 numbers together in each block first. Then you count how many blocks there. Okay? There's a remainder. Yes, Justin. You see, you did too fast. Everybody follow you. Give me the same answer. They trust you. Okay, there's a remainder, right? And so 2019 is going to be 2015 plus 4. 2015 is divided by 5. Okay, you don't need to know how many blocks there. Okay, 5 is 4. So the last one will be partial block. So it'll be 3, -7, 5, -2, -3. Okay. So add them together, it's going to be -2. The last sum is going to be -2. So all the other blocks, complete the blocks, has, right? The sum is going to be 0. So 0, 0, 0, 0, 0, 0. You know, you regroup them, regroup those numbers into blocks. Okay. So the answer will be the totals. Sum is going to be 0 plus 0, you know, 0 and plus -2. So it's -2. Ooh, that's interesting. Okay. Yeah. So let's do one more problem. If we did not get it at the very beginning, now you should be able to do that. Okay. Given the sequence of, okay, 2, -4, 5, 6, 2, -4, 5, 6, and so on. Okay. Find the sum. You probably need a calculator this time. Okay. Find the sum of the first first 102 terms. Okay. Please do it. Can you do that? No? You see, you can look at the pattern, right? Figure out the repeated blocks, right? 2, -4, 5, 6. 2, -4, 5, 6. That's the one block. So just repeat it, right? Let's repeat it. Right, so repeat it. So we have to do is regroup those. So the sum you can add right? And the last one is also 2 - 4 + 5 + 6, but you have to add as a partial block. Okay, so question, how do you get a partial block? You see, 102 is going to be 100 + 2. 100 is divided by 4, okay? If you divide 4, it's going to be, I think it's 25 times 4 and plus 2, okay? 25 blocks there, right? And the 2, the last one will be just 2. 2 minus 4, right? Oops. So it's weird. Okay. Yeah, it's 2 minus 4. It's -2. So that's why, so the sum is going to be, you add all the 4 numbers in each block. The value will be, okay, will be, what is that, right? So -2 plus 5, 3, 3 plus 6 is 9, okay? So it's 9, but there are 25 blocks there. And then the last one will be -2 because 2 minus 2 plus 4 is going to be -2, okay? So 2 plus 2 minus 4, yeah. So now 9 times 25, right, minus 2 is going to be 223. Great. 223. Why is 227? Okay, 223. Okay. So the idea is that you have a long sequence of numbers. You want to add them together, but you notice that there's repeating blocks. Okay, but each block you can add the same. All the numbers the same, so you add them together first. You add all the numbers together first, and you get the same number in each block from each block. Then you count how many blocks there, and also the partial block in the last one. Determine the partial block, you have to use a remainder. Okay, if the remainder is 2, the partial block contains 2 numbers. The remainder is 3, the partial block contains 3 numbers. That's what I did. Can you get it? Okay, so yeah, I see that only a couple of students did it correctly. So I still have to ask you the question, okay? Given the numbers, given numbers 3, -4, 5, -6, okay? And then 3, -4, 5, -6, and keep it going, okay? What is the sum of the first 2019 terms? Okay, please do it. So you figured out, you know, the repeating blocks, right? The pattern. Okay. So the pattern, you have, you know, you add them together, so it's going to be 3 minus 4 plus 5 minus 6. 3 minus 4 plus 5 minus 6. And just keep going. I don't know how many blocks there. The partial block also, this is a partial, partial block, right? All right. So the partial block, you have to determine how many blocks there. That means 2019, right? Divide by 4 this time. Let's do it. Divide by 4. 2019 divided by 4. And then 1 to 0 form, right? 3. Okay. So it's going to be 504 times 4, okay, plus 3. Okay, so there are 504 blocks of 4 numbers, okay, and then plus the partial block was 3 numbers. That's it. That's use, right? So now, can you figure it out right now? All right. All right, the sum of the numbers in each block is going to be -2, right? So how many blocks there? Each time you get a -2. So the sum is going to be -2 plus -2 and -2, right? How many negatives there? 504. And plus the last partial blocks, 3 numbers there, -4 plus 5, okay? Right? This is a partial block, it's still there. So then you get -2 times 504, and then plus 4, okay? So you can, by hand, you can use a calculator, you can do that, right? So what you get here is 1008, -1008 plus 4, it's -1004. I don't know, how do you get 4028? All right. Did you get it? William Ma, you got the same answer. Okay, good. So the idea is you have a sequence of numbers, there's a pattern there, and then you know, many blocks, each block have just regroup the numbers. You cannot add all the numbers like that, right? Regroup the numbers, and then then add the numbers in each group, then you get the same number. Okay. Right, our next problem is, okay, we want to, okay, find out how many numbers are there, and when divided by divide by 9 gives you the same quotient remainder. Now, what do you mean same quotient? Means the quotient is equal to the remainder. Okay. So I'll give you an example. I'll give you example 10 is one of the number. Why? Okay. Why? Because 10 when it's divided by 9, it's 1 times 9, and the remainder is 1. So this 1, the same. Quotient equals remainder, right? Quotient is 1. The remainder is also equal 1. Okay? So how many such numbers with this property? $19 when it's divided by 9. The quotient is 1. Yeah, remainder is also 1. Gosh, Jackie gave me 2 and a 0. Okay. I want you to count all of them. Okay. Now, first of all, the remainder cannot be larger than the divisor, right? So there's a limitation there. So the remainder is always less than the divisor. Okay? Right? So the remainder, the largest possible value for the remainder is 8. Yeah. So the answer will be 1 times 9 plus 1, 2 times 9 plus 1, right? And so on. Okay? And then 3 times 9 plus 3, okay? So this is the numbers when divided by 9 gives us quotient equal to the remainder, okay? And the 4 times 9 plus 4, and so on. And 8 times 9 plus 4, plus 8, okay? And that's it. You cannot say 9 times 9 plus 9. 9 times 9 plus 9 is going to be divisible by 9. So this is the largest remainder you can get. Okay? So you can even get all those numbers. Now those numbers, if you take yeah. So these numbers you get 10, right? If you take a 2 out, it's going to be 20. It's 30, 40, and this will be 90. Okay? No, it's 80. Yeah, 80. Yeah. Okay. So you can get all the numbers even with this property. So there are total 8 such numbers then. Okay, 8 numbers. You're right, and you can get all of them. Okay. All right, yeah, let's okay, we know that two-digit numbers a two-digit number, okay, has a remainder of 7 when it is divided by 9. And it has a remainder, the different remainder here. Remainder of 5. When it is divided by 7. What is that two-digit number? All right. Okay, so remember this is 7 same, right? Divided by 7. So you use here's the idea. Okay, you lose the first condition, a two-digit number, right? Is divided by 9, then it should be equals, then it should be 9 times the quotient, right? Plus the remainder 7. Now this time you're going to divide by 7. So you really don't need to worry about the 7. It's always divided by 7. Okay? Right? When it's this is use the first condition, this number is going to be 9 times quotient plus 7. What you really needed to worry about is this. But 9 is going to be 7 plus 2q. Okay? So that means you have a 7q plus 2q plus 7. Now, what is really gives the remainder is determined by this part. Okay? This gives the remainder. It's not exactly the remainder, but this is supposed to be, right? So look at that. This is a divisible by 7. So what they should do is the remainder is always 2 times the quotient. Okay, we don't know what is quotient, but we want to make sure this is going to be 5, right? This is supposed to be 5 when it's divided by 7. Okay, so an even number divided by 7 gives you the remainder of 5. What is that even number? Now, if you don't do like that, you can just list all of them, okay? You list all of them. You just say, hey, this number is going to be 9 times, 9 times, it must be a two-digit number. So 9 times 1 plus 7, and you can 9 times 2 plus 7, and then 9 times 3 plus 7, and then you're trying to figure it out 9 times 4 plus 7. There are not many 9 times 9 plus 7. The last one should be 9 plus times 10. Then it's not going to be a 2-digit number. So then you check, find out which one gives you the remainder of 5 when divided by 7. When you divide by 7, you really don't need to worry about 7. You just need to figure out which number, okay, gives you the 7, okay? Then to give you the remainder of 5 when it's divided by 7. Oh, well, it's easy to, from here, yeah, you can decompose the 9 again, by 7 plus 2. So eventually the remainder here, when divided by 7, the remainder is determined by, here's 2, determined by 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 8 is the remainder, divided by 7 is 1. Right? I'm just only talking about the remainder, okay? Then 9 times 5 plus 7, the remainder is 10, and then divide by 7, and you change it to the 3, okay? And let me quickly erase that. So we only consider the remainder, right? And then this is a 9 times 6 plus 7. So if you, first of all, you get 12, the remainder divided by 7, it's 5. Okay, 12, yes. Okay, this is the number, okay? Yeah. $61. So this is 61 is the number. Yeah, 61. 61 divided by 7. Is going to be the remainder 5. That's in the middle. Just check, go through one by one. Okay. Yeah, so remainder is from 2, 4, 6, 1, 3, 5, blah, blah, blah. You find the one, then you check it. This is the correct answer. Okay. Oh, it's 10 o'clock. So we stop here, and you have a chapter 10 for practice, okay? So unless you don't have the book, let me know, and so I can send you the scanned copy. So please complete the problems, and if you have questions, you can always ask me. And